In this video, we're going to discuss the Creaform MetraSCAN 3D scanner and the Creaform HandySCAN 3D scanner. And what we're going to do is we're going to take a couple of plastic automotive trim pieces and basically scan both of them with these two scanners and just kind of show the differences in the workflow. Now we have some other very detailed demonstrations that go into each of these products, and I encourage you to watch those to really get into all the features of each one. But what we thought we'd do here is just kind of show the setup and the actual scanning using these two different technologies. Okay, the first part we're going to do is a grab handle. You'd find this typically on the A and B pillars in a vehicle. It's basically a grab handle to get in and out. So you can see we've just hung the part in a way that we can basically scan all the way around it. So this is what we call static mode on the MetraSCAN. There's also dynamic mode. But since these parts are small, they don't really lend themselves to dynamic mode where we apply a few targets. So we're just setting it up in a way that we can scan all the way around it in a single setup. And we're jumping back and forth between the 14 laser line mode and the single line mode. The single line mode lets you get into nooks and crannies and deep holes and pockets, which on the back of this handle there's some of that. And the 14 line mode basically lets you scan faster. So we can jump back and forth. And again, in the other demos we've done on the MetraSCAN, we go into a lot more detail. But we basically just keep working our way around the part until we basically have it all scanned. And you can see the screen up in the corner. That's capturing it in real time, so we can watch that as we go. And we just basically keep filling it in. And again, I'll jump back and forth between the single line and the multi-line mode, and just until I see on the screen that I've captured everything. So the advantage of this is it's very quick. I can do it in a single setup versus maybe setting the part on the table, scanning it, saving it, flipping it over, scanning it, because then I have to align those two data sets, merge it, clean up the extra data. This is just a faster way to do it. So for a lot of small parts, we really prefer this method. If there's a way we can kind of just fixture or hang the part, which typically there is, this is a great way to do it. So once I'm done, I'll hit stop scan, and you can see we were able to scan this part in less than a couple of minutes. We can zoom in, take a look at it, make sure the data looks good, and we can change the triangle size, and we'll change it down here and reprocess it. Basically that goes back to the raw point cloud underneath and repolygonizes the mesh to a larger or smaller size. Basically it's going to give us more fidelity. And then once that's done, we can export it into an STL file for reverse engineering or inspection processes. We can also do some basic editing here and clean it up. Okay, for the next part, this is a A-pillar trim piece, again on an automobile. And same thing, the dynamic referencing doesn't lend itself necessarily to a small part like this. So again, we've fixtured it up in a way that it's basically up in the air, and that's going to allow us to pretty much scan 360 degrees around it. So again, I'll use both the 14 line mode and the single line mode, and you'll see me jumping back and forth to scan this part. So this one will take a little bit longer because there's lots of ribs, and some of these ribs are very close together. So because all scanners are line of sight, you'll see me moving around quite a bit. And what I'm basically doing is just trying to hit, especially on this back side, if we want to capture all of this data, you're going to see me hit the surfaces from all different angles, just to try to get down into some of these really narrow spaces between those. To get those sidewalls is a little difficult because they're so close together. And basically both of the sensors, both of the cameras on the head there have to see the laser lines as they hit that surface. So it's just a lot of moving back and forth, going from that single line mode to the 14 line mode, and really just working your way around the part. So it's important in this setup again to try to fixture the part in a way that you can basically grab or see the entire part. Otherwise, again, you'll have to set it up twice and do it. And there's nothing wrong with doing it that way. I just prefer this method if I can easily fixture it up in a way that I can get all the way around the part. It just makes it easier. It's less work on the post process, less cleaning up of the data, because typically if you lay it on the table, you're picking up the table. You'll see that here in a few minutes with the HandySCAN a little bit, but again, you just keep working your way around. there's no automatic button or light that comes on and says, hey, the whole part's scanned, you're all done. It's really just scanning it, maybe stopping and looking at it. If you see some areas that you missed, you go back and you hit them again. But with a little bit of practice, you get a pretty good idea of what it takes, to get the whole part. Now, again, you don't see the C-track, which is the camera system. It's actually backed by the camera. But if you haven't seen the full MetraSCAN demo video, basically there's a camera system that tracks that head. So all of those targets that you see on there, those round little dots, basically the camera system is tracking that head in space. And then there's two more cameras that are on the scanner itself, and they're picking up that laser line, that either single line or 14 line. It's actually picking up how that shape distorts over the surfaces, and through a process of triangulation is picking up the 3D shape. So you can see I'm coming back in here in that single line mode, which again will get into tighter spaces and areas than the 14 line mode, because it actually orients the laser in a different position and basically fills it all in by having that different orientation, and the camera's focused in on that. So you just really keep going over this until you think you've got the whole thing covered, or what's important to you. In this case, I'm trying to scan the part and get all of it if I can. Other times I maybe only need certain areas, and certainly you would only scan those areas. Now, the only downside to this method, called the static mode, is you cannot move the part while you're scanning. So this would be similar to other technologies out there. You just can't move the part. If you move the part, then your scan data would be misaligned. And that is the advantage of the dynamic mode, which on a part this size you theoretically could do the dynamic mode, but again, if you do a good enough job fixturing it up, it's really not required. And again, with a little bit of practice, you shouldn't have any trouble scanning it without moving the part. But again, if you bump the table or whatever, moved it around, basically you would just have to stop scanning, save it, start a new scan, and then merge the two. So we're done scanning. This will take a few minutes to process, depending on what you've set your resolution to. But obviously, the longer you scan, the longer it will take to process, because it's taking that raw point cloud and again turning it into a polygon mesh or an STL file, basically triangles. So it filters through all of those points and gives you back a very nice, clean, equally spaced triangulated mesh. And depending on the resolution you've set will make the difference. So once we're done, we can look at it, we can zoom in, make sure we've covered all the areas. And again, if we haven't, we just hit scan again, and we go back and we finish scanning whatever areas we missed. But it's very easy to see that you've scanned the whole part. Okay, so that was scanning a couple parts with the MetraSCAN scanner, and that was all in real time. There was no editing to the time it took to scan those files. The screen capture was live the whole time. Basically, you were seeing it in real time. So, the handle took about a minute or two, and the trim piece took, I think, maybe about 4 minutes. Again, you could go back and look at the video, but that again was all in real time. So now let's talk about the HandySCAN and how we would scan those same two parts and what that setup would look like. Okay, so we'll go ahead and start with the Apillar, and you can see I've got a few targets on one side of the Apillar for the HandySCAN, because it does require targets. Now, the targets don't necessarily have to be on the part, but the scanner has to see targets at all times in order to scan. So you can see we've got a few on one side of the part, and then you can see we have this targeted mat, and we have some fixtures that we're going to use basically to elevate the part, and then the little triangles will explain. So we'll get this all set up, and we'll show you how to do it with the HandySCAN. Okay, so you see we have basically put this trim piece on that targeted map, and we've used those little fixtures just to raise it up off the mat a little bit. And this will make more sense when we get done scanning this side, but basically it makes it easy to edit the scan file. So the first thing I do is I quickly move around and I try to pick up all the targets on the mat and on the part, and you can see they're red and white. So the red targets it's using, the white ones it knows about, okay? And you can see we're just going to start and work our way around. Now, theoretically, you could just target up the whole part and scan it. The advantage of that is you could kind of hold it in your hand or move it around. In this setup, once we set it up, we can't move the part in relationship to the targets. But when you have a part like this that's small, and it's got a basically sharp transition to get from the front to the back, it's very difficult to try to just target the part and scan the front and then flip it over and scan the back, because you essentially have to be able to see at least 3 or 4 targets on the front side before you can flip to the back side. So you'll see how we're going to flip this over. But just like with the MetraSCAN, it has 14 laser lines. It has the single line mode. So your scan data should look pretty much identical to the MetraSCAN when all is said and done, assuming you do the same quality job of actually scanning scanning the part here. So again, I'm using that single line laser mode to get into areas. I'll jump back to the 14 line mode, and you can see I'm picking up some of the table below. I've tuned the laser for this particular color part. If you go back and watch the detailed demonstration of the HandySCAN, you can see that it's very quick to do, but basically you control the power of the lasers and then the sensors for the type of surface finish you're scanning. So that's why it's picking up the part well, but not picking up the table so much underneath, even though it is getting some of it. So again, we just keep working until we get it all scanned and we feel that it's scanned well. And again, we'll take a look at it because we don't want to move this part until we're pretty comfortable that we've got all the data captured, because otherwise we're going to lose that relationship with those targets that are on that table. So we can spin around, zoom in, look at it, make sure it's covered. We've got complete coverage. If we don't like it, we can hit the scan button and keep scanning. So we'll do this until we have it all. Now the next thing we're going to do, if we're happy with the results, is we're going to delete the targets. And we're going to delete all the targets except the ones that are on the part. So I've gone in here and you can see I'm windowing in. I've gone into a side view and I'm windowing in all the targets that are on that table. And if I rotate it around and take a look at it, you can see they're all highlighted. The targets we're not deleting are the ones that are on the part. So that's one of the advantages of this software, is I can delete just selected targets. So I windowed in on all those targets and I deleted them. Basically meaning the software doesn't know anything about those targets anymore, but it still knows where the targets are on the part. Because I'm going to flip it over. I flip my fixtures here, and we're going to put the part upside down, and then we're going to drop in these little triangles here in a minute, and those will just help us to get those vertical surfaces better. You'll see that here in a minute. So I want to put it back on that targeted mat, so I've got targets all the way around, and I'll throw these little, let's call them vertical helpers. This will make more sense. Now, it's hard to see here, but we can still see the targets on the side of that part. You can see them there. The side of that part, those targets are there, and what I'm going to do, I'm going to start scanning, and I'm actually going to aim right down, and you can see it flips over immediately because those targets were still known. Those targets were still in the file. So I grab those to get, basically get oriented with the part. Then I'm going to quickly scan around to get all the targets on the table and basically rebuild my target map so that it knows where they all are. And then I'm going to just start working my way across the part like we did the other side. Now, as with the MetraSCAN, this side of the part is a little more difficult. You have all these ribs, these little tabs sticking up. You've got some small holes. So, this side's going to take a little bit of work, like the MetraSCAN, to scan. And as long as I have targets in my view, it will pick up and scan that part. And you just keep working your way around the part. Now, the little triangles, those are nice. Just as I lean down to try to get like the bottom of the part, it just gives me a few more triangles kind of in the vertical direction. And sometimes we'll put like we have just some pieces of like aluminum square tube, and we'll put targets on those and stand them up in the view. They're not necessarily required, but sometimes they are nice if you're trying, because if you lean that scanner over too far, it's not going to be able to see the targets on the table. So that's all they're there for. And again, if they don't work or you don't like them, you can take them out, go in the software, and just delete those targets so it's not trying to find them. And again, we can stop and start scanning at any time. But we find on parts like this that are long and skinny and don't have a lot of depth or thickness to them, that this is a really good way to scan, because it's very hard to if we were to just target the part, trying to scan one side, you can't just flip it over and scan the back side. You've got to continue that target map all the way around, and you just can't get around a 90-degree corner on a thin-walled part and get to the back side. But again, this is the preferred method over scanning the part, saving it, flipping it over, scanning it again, and then taking those two data sets and aligning them and merging them. You can do it. It just, in my opinion, it takes longer to do versus this method. You see it was very quick to flip from the front to the back. So this is really a great way to scan the part. Okay, so now we're done, or we think we're done. We hit stop scan, and just like before, we can go in and interrogate the data. We can zoom in, zoom out, move around, and make sure that we've covered everything that we want to scan. Now, if we want to get the whole part, that'll obviously take longer than just maybe the front side, or maybe we don't need all the ribs. It all depends on what your application is. If you're doing reverse engineering of the whole part, you'll want to do a good job. If you were inspecting it and only wanted maybe the tabs or certain areas, you could just do that. Once again, we're changing the resolution of the scan data. Many times we'll scan at, let's say 1 millimeter, and then when we're done, we'll process it down to a smaller size and then export it. It scans a little faster when you have higher res, because it's just for the real-time data collection, and what you see on the screen, it just will go a little faster. But that's really personal choice of how you want to do it. So the process here will definitely take a little bit longer because the amount of data you have to process. But again, this is all in real time, scanning the part and doing the processing here. Once this is done, we can again take a look at it and make sure we have what we want, what we need. If we don't have everything, we'll want to definitely not move the part and scan it. And it's not the end of the world if the part did move. You would just go back, delete those delete those targets, just keeping the ones that are on the part. That's why we have a few on the part, because then we always have at least some reference geometry tied to the part. So you could delete them all and then do it again. So again, we'll take a look. We can zoom in, rotate around, and make sure we have everything we need here before saving the session and then exporting the data out. So here's our final results, and again, the HandySCAN and the MetraSCAN data, as far as the quality of it, should look really the same, because they basically use the same laser and sensor system to capture it, just a little bit different in the actual workflow. But again, the data itself should look very, very similar. Okay, so the last part we'll do is the grab handle again. And you can see we've used, in this case, those little triangles as our fixtures just to lift it up. You can see, again, we've put a few targets on the side of the grab handle. So we'll have that reference. And again, we'll start scanning, picking up both the targets on the part itself and then also the table. So just like before, we just kind of digitally spray paint it, moving around. Sometimes we've got a little Lazy Susan that has targets on it, and then you can just rotate your part around. That's nice. The only thing there, again, you have to be careful if you've got targets both on the part and on the table. When you rotate that around, you want to make sure it's secure and doesn't move. We typically would use that for bigger, heavier parts, maybe big castings and things like that. So again, going back and forth using the single line mode to get down into some of those deeper areas, down in those holes around the part, and then we can again switch back and forth to the 14 line mode. Again, small parts like this, you can almost use the single line mode for everything, but the 14 laser line mode is certainly much faster. So we'll just, again, keep working our way around it. And now this time you'll notice we've got the laser turned up a little bit higher, and we did that so we'd actually pick up the table as opposed to last time, just to show you some of the mesh editing tools. So again, I'm going to flip the part over. Now, the triangles don't work well to hold the part upside down, so we'll go back to these other little fixtures, and we're going to, there's a couple holes in the handle, and we'll just stick it through. Again, I want to keep the part off the table because, as you're going to see in this instant, we were actually picking up the table, and it just makes it more difficult to edit later because we got to try to delete that table essentially away. So we flip the part over. Now we're going to get in a side view here like we did before, and we're going to go in and select all of those targets except the ones that are on the part. So we just kind of window in to capture all of those targets, and we'll rotate it here so you can see them. So everything in orange, and then hit the delete key, and that will delete all those targets. Now the other thing, once this is done, we're going to do is we're going to delete that table data because we've flipped the part over, and if we actually start scanning, since now the part's flipped over, all that table data will be there, and you basically won't be able to see your part because the table data is kind of covering it up. So we want to delete that anyway, so now will be a good time to get rid of that data. Otherwise, again, when we're scanning the part, it's going to flip over and you won't be able to see through that table data there. So plus the triangles are no longer there. So what we do, again, same thing as we get into a side mode here. We're going to click Edit Scan, and there's some really nice tools in the software here. We're going to select it. We want to select through and basically get everything basically through, not just the sides you can see. And again, if we rotate over, now that's all selected, and we're going to delete it. Okay, so at any point could we go in and delete both the targets and scan data. Maybe there's an area we scanned that just didn't look good for some reason. You could delete it, or you've picked up things that you just don't want. So now again, you see me hit the button, and we're going to start always on those targets on the part, and then go move around to kind of capture all the targets, and then get back up on our part and start scanning it. So again, if you remember before, if we wouldn't have removed that table data, it would be very difficult to actually see the part because that table data would be there. So once again, we just work our way around the part. You can see it's pretty easy. It's pretty intuitive. Basically, you see in real time what you're picking up. There's definitely some deep slots on this side of the part that are difficult to get into, and some of them are just impossible. But we'll go into that single line mode again and try to get as much of that data down in there as we can. But certain areas are just impossible. Scanners can only not only, like I said, are they line of sight, but it's also the convergence of the two cameras and the laser. So we'll take that single line mode, and we just hit it from different orientations, trying to pick up as much data as we can. By orienting the cameras differently and moving it around, you're just trying to pick up as much of that data in there as you can. But it's definitely a visual process of kind of and it's experience, knowing when you've captured all the data. But if you keep going over an area down into a crevice, and you'll kind of reach a point of no return where it's just not picking up any more data, no matter what angle you hit it at, then you're just not going to get any more data. So once again, we hit process. That's going to take our raw point cloud, and it's going to convert it to our triangulated mesh at whatever resolution we're set at. As long as you save this session file, you can open it up later and reprocess to a larger or smaller triangle size, and that can be quite handy. Maybe there was some small detail that you didn't get because you had let's say a 2mm triangle size. You could go back and reprocess the file down to a smaller amount. You could even process just certain areas of it to get higher fidelity and pick up smaller features in that area. So there's our scan data. Again, we can zoom in, look at it, pan around. In this case, we'll want to go in and delete those posts and triangles and everything out of that data, because we don't want that. Now, depending on your workflow, if you were going straight into inspection software, you would delete it all here just to get rid of it. If you were going to some other reverse engineering software, you might do the deleting there, but it doesn't really matter. You can delete it, but that's it. We just export it and the process is complete. So this concludes the demonstration of the HandySCAN and the MetraSCAN. At the end of the day, when you're done, pretty much the same results, same data quality. It really gets down to what's the right tool for you. The MetraSCAN, certainly if your parts were much larger, that's where the MetraSCAN is really going to shine. But on basically smaller parts, they're both worthy products. It's a little bit different setup and workflow, but again, at the end of the day, you get pretty much the same high quality scanning results.